When I close, everything is finished, right? Please, please, please don't touch. Only touch your microphone, your camera. That's it. No more. Okay, go back. Come back to the whiteboard. Do you see whiteboard? Okay. Let me try to maximize. Okay, so now this system contains 3 equations, 3 unknown. Okay, this is perfect determining. After I want to explain in detail, guide the classification for the system, because normally we solving 3 equations, 3 unknown, 2 equations have the same number of the equation and the same number of unknown. But no, in this chapter, I want to explain any possibility and what is the solution can you apply in this case. Okay, so let's move on to the matrix. The matrix, what is the matrix? Matrix is the rectangular array of numbers. So far is definition, but maybe you don't understand very well the interpretation, no? But it's a definition. Basically, therefore, you define, for example, a matrix. I don't know why always using capital letter to denote a matrix. So the matrix A in our system is always the matrix formed by coefficients in front of the variable. The coefficients are 1, minus 2, positive 3, 2, 1, negative 4, negative 3, positive 4, and negative 1. So basically, the only thing that we are doing is taking the coefficients. Look. Okay, in this case is 1 here, negative 2, negative 3. This is the idea. This is so the first row of our matrix is 1, negative 2, and 3, que is exactly the coefficients in the first equation, and the coefficients in the second row of our matrix is 2, 1, and negative 4, que is exactly that number. Look, sorry, this, and this. Okay. And likewise, the last row is negative 3, positive 4, and negative 1. It's important to understand that our matrix contains 3 rows, let me write here, 3 rows. And the number of rows is exactly coincident with the number of the equation. Okay, we have in my problem 1, 2, 3, 3 equation, 3 rows. And the number of column, no necessary. Column is 3, que is, you know, 1 column of the X. So you organize the equation in elegant standard form, you write this is the column, is the column for the X. This column is the column of the Y. And this column is the column of the Z. So basically, in this moment, I want to explain the dimension. What is the dimension? Dimension of our matrix. The dimension in this matrix is 3 by 3. This first 3 indicate the number of rows, and this second 3 is the number of columns. This is a convention, guys. So 3 by 4, or 3 by so on. So the first number indicate the number of row, and the second one the number of column. By the way, in this example, this matrix is a square matrix because there is coincident the number of row and number of column. But no, not always. You see in a few minutes, in a few seconds, another matrix is not a square, a rectangular. Okay, now we have also, bueno, define B matrix, that is formed by the number in the right hand side. So basically here we're using to define the A matrix, and this you're using to define B matrix, no? And B is 4, 3, and negative 2. This is a matrix also, but this dimension of this matrix is 3 by 1, because that matrix have 3 rows and 1 column. And normally this vector can look like similar to this is called column vector. So the word vector is equivalent to the word matrix, but the vector is using when the dimension is 1. When the dimension is 1. Because it's similar to the notation of the vector. Actually, it's no vector, but it's the terminology. Likewise, and another thing we study in your moment, we have another vector, suppose C, not in this example, another example can look like that, for example, 4, 3, and -2. Oh, the dimension for this vector is 1 by 3, because this vector, or this matrix, sorry, have 1 row and 3 columns. And this is called a row vector. But no, we study in your moment, not now. In another example, maybe not today, because we dedicate one entire lecture to explain in detail the operation using matrix. Okay, so now, for example, very important now for today, you put A and B together because the system have 2 bars, A and B. You put A and B together like that, A and B, and one new matrix. Well, so let me try to do my best. AB matrix is, you copy A, 1, -2, 3, 2, 1, -4, -3, 4, -1. You put a vertical line. Okay, by the way, guys, the vertical line, they only indicate to separate the coefficients in front of the variable and the number, just the number in the right-hand side, okay, is 4, 3, and -2. And this new matrix formed by the A and B is called augmenting matrix. Augmenting matrix. One of the reasons it's augmenting is because you put together A and B, no? And you have in this moment all the numbers that perfectly characterize our system. Keep in mind that the column 1, the column first column is X column. This is the Y column. This is the Z column. Okay, not necessarily to write the variable, no? It is only for the academic purpose. And this is the right hand side numbers, okay? And I'm just gonna hey, noise. Who make a noise? And the row represent the equation 1, the equation 2, and the equation 3. Okay. Entonces now, let me erase this line. Let me write this letter because it's not necessary. And sometimes this vertical line, see, you are doing by hand in a piece of paper, yes, you write this. However, when you're using the computer, you want to explain your moment, the computer never put this vertical line to separate coefficients in front of the variable and right-hand side. Guys, so far, everyone following? It's only terminology. Only try to remember this. Everyone follow me? Everyone understand a little bit, no? The idea of the organ. Yes? Okay. Okay. So now, let me verify that you understand. I bring a hard, no, weird example in which the only thing you should do is I have the system, it's given now. Now you have to write the augmented matrix associated with this system. Okay, let's try. I want to copy example 2. Example 2 is confusing. Example 2. Okay, example 2 is x plus y equal to 20, equation 1. Z plus y equal 40, equation 2. And x plus 2y plus 3z equals 60. Equation 3. And it's my system. And the only thing I need to do now is write the augmented matrix associated with the system because it's the point to start the analysis. So we are doing the analysis using this. Okay. How many equations you have? How many equations? How many? Come on, activate the microphone. How many? Or send me text message by the chat. How many equations? What happened, guy? Are you hearing me or not? What's going on? Nobody said something. How many equations you see using your eyes? Only eyes. How many? How many?
Three.
Three equations. Entonces now, Rebecca. Entonces now, when I set up the matrix associated with the system, because I want to solve it by computer, by hand, either way, of course, how many rows should have our matrix? How many rows? How many rows? How many rows? Kiana, Jose Cabrera. How many rows? How many rows? No idea. The row is coincident 100% with the number of equations. So we have three equations. We have, Rebecca, we have three rows, Rebecca. However, how many columns? Remember, the column is associated with the variable. We have X, we have Y, we have Z, and we have the right-hand side, no? So basically, my matrix at least set out 1, 2, 3, and 4 containers. And inside the container, I put a variable. But what's the problem? In this weird problem, because sometimes in one equation, one variable is missing, pero no problema. Because the container is here, pero si es missing, that means que the entry is 0. Okay? Okay, let me try. This look like a little bit easy, but not always is too easy. Look, I know that my matrix, augmented matrix, of course, contain 1, 2, 3 rows, 1, 2, and 3 rows. And contain, I suppose, 1, 2, 3, and 4 columns. Is the column of the X, is the column of the Y, is the column of the Z, is the column of the right-hand side. Normally, we using always to enclose the number inside the matrix, a square bracket, big square bracket. Another book using parentheses, but I prefer square bracket. Okay, so now you see in the first equation, the coefficient in front of the X is 1. The coefficient in front of the Y is 1. But we have no Z, that is missing. And the right-hand side is 20. And this, I put a vertical line to separate the coefficients in front of the variable and the right-hand side number. And the second equation, wow, I don't see any X, so it's 0. 1Y, I put intentionally to confuse you, and completely opposite to the alphabet order, but you know, and the problem is giving either way. So say Y, C is 1 again, and the right-hand side is 40. And the last equation, nice, because everything is clear, everything is completed. 1, 2, 3, and 60. By the way, the matrix we start working now is the matrix whose dimension is 3 by 4. So 3, 3, 3, 3, 3, 3, what? 3 row 1, row 2, and row 3. That depending of the number of equations. And also, vertically speaking, column 1, let me use another column, column 1, okay, by the way, is the column of the X, column 2, que es the column of the Y, column 3, que es the column of the Z, and column 4, que is the right-hand side number. No? Okay, this idea is super clear. This idea is super clear. Yes. Now let me see the chat. The chat said good afternoon. Yes, yes. Okay, good. Okay, let's move on to the how we operate that. Okay, so what is the idea? The idea is, guys, are doing row operations, row operations, row operation. I want to explain what is the row operation. Well, a row operation is very, very similar to the thing we are doing when you apply a elimination process, exactly in the chapter 2, but a little bit more systematic. Let me explain in detail row operations. Row operation. By the way, guys, I sent a PowerPoint. So be in the email case and the link of the Skype, I sent a PowerPoint. Of course, I graph any slide. I put it here in whiteboard to explain. But after, I recommend you watching this because maybe I have no time to cover everything. Okay, so basically we have three kinds of row operation. Okay, you see it's similar to the thing we are doing before in the elimination method. The first row operation, that one, the first is interchange to row. Okay, of course you can. Why? Because it's the permutation to equation. It doesn't matter. The system has suppose three equations. If you suppose one, two, three, and you swap 1 and 2, the system is the same. So normally you can permutation. You don't understand very well why you have to interchange, but I want to explain in the example. So it's perfectly legal doing the first row operation we study. Row operation we study now, guys. Row operation is interchange to row. Okay, cool, no problem. The second row operation is multiplication, multiply the row by a non-zero number. So you multiply any row okay, you need. For example, in this example, get the PowerPoint, I multiply, okay, be familiar with this notation. We using, in this notation, we using, look, 3 times R2 equal capital R2. What means that? Can you multiply the entire row 2, okay, this row, the entire row 2, you multiply by 3. And when you multiply the entire row 2 by 3, you get that new row. So basically, 3 times 2 is 6, 3 times 1 is 3, 3 times 2 again is 6, and 3 times 3 is 9. Okay, and no problem, because this matrix is equivalent 100% to the original before multiplied by 3. You remember that for doing elimination process, you select one equation multiplied by 3, another multiplied by 2, and suppose que es in 2 dimensions, each equation represents a line, and when you multiply this equation by 2, well, you get the same line. It's totally dependent line. It's the same line. And in 3D, well, in 3D, you have a plane. Each equation is a plane. And when you multiply a plane by 3 or by any number, you make a decision. Maybe you don't understand what number. I explained the method now. It's the same plane. It's the same plane. It's depending. It's equivalent equation. The only thing I need is multiplication because I want to apply some idea similar to elimination. Not exactly the same. More smart way. Now, finally, the row operation number 3, que in my opinion is the most important. Entonces, now, suppose this row operation. Look. This row operation is you multiply by 2. 2 is a factor. You multiply by 2. 2 is a factor. Multiply the entire row 1 by 2. And you adding 1 by 1 in the corresponding position with the row 3. And these new numbers you store. You can use it if you want no equal signs, arrow, because you move into the new row 3. So there are several new notation here. Okay, I need to explain in detail. Capital letter R represent new row. So when you're talking about capital R3, it's a new row 3. So you're talking about R3 no capital, lower case, entonces the old, the original, this given. This is a symbolic way to indicate the idea, right? Entonces, let's do it. I need to understand this. So you multiply by 2. Let me try 2, 1, 2, 3, 4 times, 2 times 2 times 2 times 2, 4 times. Let me try to put it marker. You multiply the element in the row 1. The element in the row 1, the entry, it's the element or entry, is 2, is 1, is 2 again, and this is 3, no? The basic that number is this number. Plus, you adding plus. Row 3. Who is row 3? Row 3 is this guy. But in the same position, guy, vertical. So these 2 correspond with the 5. This 1 corresponding with the 5 is a coincidence. These 2 correspond with the 1. And these 3 correspond with the 0. And you compute that. Let me try. So it's 2 times 2 is 4. 2 times 2, no, 2 times 2 is 4. What's going on? No, I make a mistake. Sorry. I explained wrong. Look, I am crazy. This is row 1. So basically row 1 is this. Row 1, so we're working in the row operation. Okay, I try to explain. Row 1 is this. And row 3 is this. Okay, the number that participate in this operation, row operation, is 1, 2, 3, 4. Oh, 1, 2, 3, 4. And this is 5, 5, 1, 0. 5, 5, 1, 0. I did right. This is row 1, and this is row 3. Okay, let's do it. 2 times 1 is 2, plus 5 is 7. Okay? 2 times 2 is 4, plus 5 is 9. 2 times 3 is 6, plus 1 is 7. Coincident. And 2 times 4 is 8, plus 0 is 8. And this number is the new number that you see now after the row operation and the row 3. This is the capital R3. Capital R3. This is the R1 given. This is the R2 given. Do you understand very well this, or is confusing? I know that the first time you see, maybe you don't understand very well. You understand or no? A ver. Idea. Comment. Let me go to the chat to see. Clear. Wow, Giselle is clear. Jose Cabrera is clear. Okay. Kegan, do you understand this or no? Little b. Little b is F or D. Okay, I repeat again. Please pay attention. Okay, look. Let me start at the beginning. I want to explain that row operation. And maybe you see, well, professor, we confront this. This is another problem. My challenge right now is can you understand what means that part. So the thing is, you take one factor, que two. Maybe the question can fly in the air. Maybe this is the reason that you don't understand how you select two. No, this is not my problem. My problem now I understand the operation. This factor two, that by the way I copy 4 times, you multiply each entry or element, whatever you want to call, in the row one. Que es one, que es two, que es three, y es four. That is the interpretation row one. But actually we have four. 1, 2, 3, 4, this element. Plus, according to the row operation, row 3, and row 3 is in the original matrix 5, 5, 1 and 0. Okay, is this guy. Okay, when you compute that, the answer is 7, 9, 7, 8. And you copy this element, this number, sorry, and the new 7, 9, 7, and 8, and the new matrix after the row operation procedure. This is R3, and this is capital R3. More clear now? Okay, say something. Eh? No?
Yes. Yes.
Okay, do you have B or A in that part? Huh? Okay, okay. You say now, you say, bueno, está bien, I understand this, pero I don't understand the utilization of this. What is that? What is the reason I need to do that? I want to explain now. Look, the algorithm that was created for solving the system of equation using matrix was created by the mathematician Gauss. Gauss. That is the reason that the method is called Gauss elimination process. Okay. And after that, when the Gauss discover or declare this method or prove this method, another mathematician is called Jordan, complemented a little bit, much better. The method entonces is called Gauss-Jordan. Gauss-Jordan elimination process. Gauss-Jordan. Same, but two after elimination process. What is the idea? What is the idea? Pay attention now, because this is the most important moment in the lecture. Suppose that we have a super big matrix. Super big. 40 by 40 or by 41. Because suppose que es aumenta matrix, ¿no? Ajá, entonces you copy the coefficient in front of the variable. And you copy the right hand side. This is, you know, when there's too many variables, you call x1, x2, x3, no xyz. Using so crypt. Bam, 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 and you ending here in x40, no? It's the last. Because the 41 column is the right hand side. Okay, you know, it's called B, but you call B1, B2, and so to B40. Okay, so now suppose that here we have a number 2. Pero no, I don't need 2. I need 1. Why? I need one because this is our first pivot. And you understand very well what is the pivot now. Well, suppose I need to create a pivot, I need one, not two. So suppose in another equation, bam, 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 and the equation 25, maybe, we have 1, 1. This is the equation 25, no? And this is the equation 1. Oh, okay, you say I can swap, o sea, interchange the row 1, interchange row 25. Wow, cool. So immediately, this 2 is coming down, this 1 is coming up, and now we have a pivot equal 1. Exactly we need to start. Bueno, okay, the question is flying there. Bueno, professor, if we never have coefficiency 1, okay, no problem. I solving. How you solving? No, there are no equations that contain coefficient 1. Okay, no problem. No swap. No swap. You take the row 1 and divide by 2 and store in the new row 2. Yeah, I create this one here. Bam, because 2 divided by 2 is 1. Everyone follow me so far? So I need pick 1 in the first pivot. I need 1. So now magically I do something in order to create 1 here. And it's my first pivot. And using this pivot, I try to make 0 below the pivot. I want to explain how. Below. 0, 0, 0, 0, 0, 0, 0 until I finish. This is the algorithm. This is too long. I understand. We are doing some problem by hand, but not too much. Now, after we are doing this using the calculator, the computer and software. Okay, so now how are you doing this? Well, suppose we have no 0. Suppose in the first number we have 2. It's just examples, or 40 or -2, whatever. And you apply row operation. How? You are do row operation like that. Look, you take the row que contain the pivot, que es row 1. You multiply by magic factor, que es -2. Where I come from, -2, professor, it's the same number, but opposite sign. And you add in row 2, and the new information you put in the row 2. So when you perform this row operation, -2 times 1 plus 2, oh, it's obvious que es 0. Yes or no? Entonces I create, so I modify, pero I modify, hello, I modify, this is 0 now, nice. I modify the entire row 2. Even this guy is a new one. But it's okay. Suppose another example. Suppose we have 3 here. Or -3. Or -3 in the third row. Okay, so now my job is take the row 1, que es the row que contain the pivot, multiplication by the magic factor, que es 3 positive, plus row 3, and store this new information in the row 3. And magically, now we have 0 again here. Of course, I fed the rest of the number, but I don't care for a moment. Do you follow me? Do you follow me? I don't finish. This is just the beginning. Okay, suppose I have 20 and the number 4. Okay, no problema. So you take row 1 again, que es the row important que contain the pivot, multiplication by -20 plus row 4 and store in the new row 4. And now magically this 20 become like 0 again and change the row 4. Okay, do you follow me? So you apply, in this case, 40 times this idea, and you create 0, 0, and the first column. So far, everyone follow me? Relax. Everything gonna be okay for you. The problem is understand the algorithm. You understand the algorithm, no more. The complication, of course, is a huge. I know. Oh, no complication. Remember that they are a big difference in mathematics. Complicated is abstract. However, it's not abstract. It's easy, it's relatively easy, relative, not too much, but it's long, consuming time. It's another thing. I understand. But when you have a long job, we're using computer, and a computer go fast and solving my problem. Okay, so I finish the first column. Okay, I finish, no? I continue with the second column. Entonces, en the second column, in similar way, I need to create a second pivot. This is my second pivot. The second pivot, maybe the best way in this case is you take the number actually we have here, 20, and divide by 20, the entire. So you take the row 2 divided by 20 and store in the new row 2. And you have the pivot. And when you finish the pivot, entonces now using row operation, the third kind of the row operation, remember we have 3 kind, you create 0, 0, 0, 0, below the second pivot. Do you follow me? Now I go. Similar idea with the third pivot. The third pivot is located in the third row here. Okay, so you are doing the one again, and using that pivot create 0 below. Do you understand the idea? Of course, you spend 2 weeks doing this by hand, or 2 months. And we continue in the column 3, in the column 4, sorry, you create a pivot 0, 0, 0, 0. Until tac, you end it in the column 40, get one here, and the rest is 0, 0, 0, 0, 0. Okay, I don't finish. Almost I finish, but I don't finish. Suppose that I finish this long process. Okay? I can solve it. Yes, you can. You can, because the matrix we have in this moment is the echelon. Echelon form. What means echelon form? Suppose to understand very well echelon, suppose no 45, 41 matrix, no, suppose 3 by 3. Suppose that we create this situation. And here we have 2, 3, 4, 5, 6, and 7. Suppose that I manipulate my matrix and this new algorithm. Now I have echelon. What means echelon? Echelon means that our matrix is, like stairs like that. Look. Okay, we have 0 below the pivot. Entonces, when you have that situation, wow, it's easy. Similar to the test. The test number 2. Okay, we have back substitution. So it's obvious. Okay, this is X, this is Y, this is Z, right-hand side number. Entonces you have que the last equation is 0x plus 0y plus 1z equals 7. Look at that. This 0 is this 0, this 0 is this 0, this 1 is this 1. Entonces es obvio, looking the matrix, que C is equal 7. Wow, back substitution. However, I move it over, and over is, this is 4. It's y, no x anymore, no. Y plus 4z equals 6. Oh, entonces it's easy because you plug in 7 here and you compute y. And finally, the first equation is x plus 2y plus 3z equal 5. Now let me finish this. This is the hypothetical problem. It's not true. After we solving the true problem, no? So basically y plus 28, no? Because where come from 28? Multiplication 7 times 4, no? Equals 6. Therefore, y alone is 6 minus 28 is 22, no? Y is equal minus 22. I'm plugging in 22 here. I'm plugging in 7 here. And you solve for x. This is called back substitution. Are you familiar with this? Back substitution. Okay, professor, but I don't like this. Because I spend a lot of time doing the raw operation. And after I finish, okay, I finish one system is relatively easier. But not relatively easier when you have 3 equations. But when you have 40 equations, it's not easy. I need to do a lot of computation. Entonces now, this is the moment in que Jordan is coming to the game. And say about, no, you don't finish. You need to continue. Okay, what is the reason? What is the reason? In the algorithm, you are doing only 0 below the pivot, and why not above the pivot? 0 here, 0 here, 0 here, 0 here, 0 here, 0 here. One more 0, no, 1, 2, 3, 4. 0 here, 0 here, 0 here, 0 here. And supposedly we have the pivot number 5 here. Okay, so basically when I finish the Jordan algorithm, the Jordan proposed, we have a system like that. 1, 0, 0, 1, 0, 0, 0, 0, 1. In hypothetical, I suppose 20, 40, 60. Guy, we don't solve anything so far. I tried to explain the algorithm. Okay, so now if you translate the matrix language to the equation, wow, this is the x column, the y column, the z column, and this is the right-hand side number. Well, I saw okay, the first row is 1x plus 0y plus 0c equal 20. Wow, this is equivalent to say x equal 20 because the rest is 0. And likewise, y is equal 40 and c is equal 60. End the story. We finished this. So basically, I prefer Gauss-Jordan. And Gauss-Jordan, okay, let me try to condense the information. The information is clear. You have a matrix, original, it's given. You somehow create your own pivot. The pivot must be 1. And that position, okay, by the way, guys, that position is the principal or main diagonal. So as the element, for example, let me do using double subscript, A11, A22, A33. What means double subscript? The first subscript is row 1, column 1, row 2, column 2, row 3, column 3. Bam, 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 and we finish A40, 40. Right? You create 1 here, 1, 1, 1, 1, and below and above 0. And when we finish that, it's too long, in the right hand side, we have the value of the our variable, B1, B2, B3, B4. Okay, super. Our question. What part you don't understand very well? Maybe when we are doing the example, you get the idea, no? I explain roughly idea. Jose, you get the idea? Benjamin, Rebecca, little bit, no? Kegan, are you leaving? A ver, no, I don't see your name, Kegan. Yeah. You don't understand anything as always, or you understand something?
Something.
Eso. Okay, now you see in the example more clear. More clear. Fortunately, we have different tools to understand that situation. Okay, the most important tools is, one software is GeoGebra. GeoGebra, in this case, it's the same GeoGebra Classic, because there are two GeoGebra, one geometric and one classic. GeoGebra Classic is a software, it's totally online. You can create account, whatever you want. You want to save in the cloud, of the account that you declare your work, you create accounts. You don't necessarily you solve it and that's it. So I want to explain in detail GeoGebra Classic, but what's the only disadvantage of the GeoGebra Classic? One of the only disadvantage is that you get the final answer, but you don't see row operation by row operation. No, unfortunately. Therefore, don't worry, because there are another tools. Okay, by the way, I want to send, so in the last email guy que on the classes over, I send the email, no, with the link of the class. Entonces I include two links. I include one link of the another software que es linear algebra, linear algebra tools kit, toolkit. I suppose que throughout the lecture, I want to illustrate both GeoGebra and linear algebra toolkit first. This is the first I want to show you. But I'm going to do fast. I prepare for you one example, actually two examples, but one is too long. I want to focus in this. Okay, now this is the conclusion, guys. Look, suppose now, okay, we have that system. All right, let me try that system. That system contains three equations and three unknowns. Okay, and immediately, so you try to solve it using matrix, you write the matrix associated with the system. Okay, 3, 7, minus 15, minus 12. I put a vertical line to separate the coefficients from the variable and the right-hand side number. This is 1, this is 2, this is -4, this is -3. And this is -4, and this is -6, and this is 15, and this is 16. So I only remove the letter, only copy coefficients. And this matrix is augmented matrix because it's the put together coefficients in front of the variable plus the right-hand side number. And now the dimension of this matrix is 3 by 4 because contain 3 rows, 4 columns. Okay, cool. Okay, entonces I want to start the long process, but not too long because it's 3 by 3, it's super easy. No justification 3 by 3, no justification matrix. Because we can do by hand. Actually, in the test 2, we don't know matrix, we are doing by hand using elimination, classical elimination. Okay, look, the first step is this. Bueno, okay, the professor explained something about the pivot. So the pivot should be 1. However, I see, wow, the easy way to see that is, look, in white color, I copy this matrix, and the yellow color, I copy the new matrix after the transformation. So now what is easy? Because in order to guarantee the first pivot equal 1, the only thing I did was interchange row 1 and row 2. So the symbolic way to indicate this idea is this. You permutation to row 1 and row 2. And the system is the same system, it's the same equation, it's the same everything, but I am nice because I have pivot 1 in the first column. Everyone follow me? Yes or no?
Yes, yes.
Okay, cool. Let me try to organize my work. Okay, what is the next? Well, the next is doing several row operation, but the third kind. Remember, in the third kind of row operation, the format is factor, multiplication by the row in which we have the pivot, in this example, row 1, obviously, right? Plus the row in which you want to change something, case in this case, row 2, and stores this information in the new row 2. It's obvious that I need 0 below the first pivot, the factor is -3. So -3 times row 1 plus row 2 stores or equal, whatever you want to call row 3. It is exactly the thing I did. Look, let me show you. I bring the next slider. Let me enlarge to see more clear. Okay, let me erase this. Why not? So I realize I need to create 0 here. How? We select -3, que is the same number that you want to eliminate, but opposite side. It's like elimination because it's +3 and -3 is 0. Yes or no? And you multiply everything. Let me try to do at least in this first example, you in the future, you accept that my computation are good, no? Suppose -3, I copy 4 times, vertical, maybe it's good. I copy the element or entry in the row 1, que is 1, 2, -4, of course, parentheses, because multiplication, no? -3. And you add in plus R2. This is -3, the factor. I copy 4 times. Plus R2 is 3, 7, -15, and -12. Equal, and put it this new number in the new one, row 2. It's obvious it's 0 in the first one. It's obvious, right? I create intentionally. Now, this is 6 -6 plus 7 and 1. Bang. This is this 0. I put in red color. Look, this 0, this 1. Let me try next. This is -3 and -4 is +12. -15 is -3. Cool. I copy the second, the third, sorry. And finally, it is a 9 -12 gets 3, -3 again. Okay, you obtain the new row 2 in which you can see clear my second 0 below the pivot. Okay. The question can maybe fly in the air. Professor, this is the only way to do this? The answer is yes. Because you try to do another disorganized way, maybe one previous work that you are doing before, you erase, you delete, you eliminate, accidentally. No, this is the Gauss, Jordan, and Gauss elimination method. It's a fantastic. It's a genius. I create that. And after, with the Nowadays, when you have computer, wow. Entonces es relatively easy using this old method, pero programming in the computer using any software, maybe Python, maybe C++, I don't know, one language, one computer language, you program this. Okay, but in this second step, because the first one was interchange to create the pivot, the second was this row operation, and you have so far this zero. Okay, what is the next step? Let me try to understand. Oh, next is this one. This one. Let me maximize. Let me enlarge this slider. Okay. Entonces I have this zero. Look, que I create a previous slider. Now I need to create zero below here to finish the first column. Oh, entonces the operation is the factor is 4 positive. It's the same number but opposite sign. Multiplication by R1. How do you know que es R1? Because it's the row que contain a pivot. This is R1. Plus the row que you want to change, que is the third one. And now you get 0. Y I finish my first column. I don't finish the problem. I finish my first column. Do you understand now a little bit the idea? I want to see face. A little bit, a little bit, a little bit, a little bit, a little bit. One pivot, 0, 0, 0, 0, 0. Okay. Now let's move on to the second pivot. Second pivot, second pivot, second pivot. Second pivot. Okay, second pivot is, let me see. Okay, second pivot is, there you go, it's this. Okay, remember, so far in the previous step, we finished the first column. We have one pivot que one, and we have 2 0 below. What is the next step? Well, the next step is you try to see we have or no the pivot number 2. Yes, we have, because by coincidence, not always happen, but in this example I create, yeah, already the second pivot is 1. Cool. So the only thing I need to do is create 0 below or above. I don't know. So let's do it first Gauss, and after we complement it with the Gauss Jordan. No? Both. We are doing both, but step by step. So now, in this moment, you multiply. So see, I want to eliminate this positive 2. The factor is negative 2. That factor is negative 2. You want to eliminate negative 2 as a factor. Multiplication now by the row que contain the pivot, que row 2. I finish row 1. Pivot 1 doing your job. Now moving to the pivot 2. Plus row 3 is the row que contain the element que I want to become like a 0. Entonces 0. I finish. I finish. I finish. I finish. Okay. Now, what should I do after that? Well, I move on to the row 3. Suppose I want to do using Gauss Jordan. No Gauss Jordan, no Gauss elimination, no Gauss Jordan. Oh, well, let me see. No. This is not the slider. Sorry. That one. That one. That one. Okay. Now, let me enlarge. Remember, so far, we have my first pivot. Everything below 0. My second pivot and everything below 0. So I need to create my third pivot because we have 3 variables. We have three columns of the matrix A, no the augmented matrix, pero the matrix. Okay, entonces es easy. The traditional way, when you cannot swap, is divided by 5, no? Because it's divided by 5. Divided by 5, look at that. Divided by 5, see, you have 5 here. 5 here, but I need 1, because the P was always 1. You divide by 5, and you divide the entire row 3 by 5. 0 by 5 es obvio que es 0. 0 by 5 es obvio que es 0. 5 by 5 es obvio que es 1. And 10 divided by 5 es 2. Okay, entonces en this moment, I finish the Gauss part. Y I have echelon matrix. And you can solve it using back substitution. Okay, suppose que you see in this moment que Z is 2. Look at that. This equation. Remember, this is the X, this is the Y, this is the Z. In this equation, the third row, last row, no X, no Y, C is 1, coefficiency, and the value is 2. Now, if you want to continue the solution of the system, well, okay, no problem, let's do it. In the second row, we have Y minus 3Z equal minus 3, no? Okay, Y is coefficient, no X, X is missing. Y1 minus 3Z equal minus 3. Entonces you apply back substitution, these two, plug it in here. Y is equal, no, minus 3 times 2, sorry, equal minus 3. Entonces Y alone is equal minus 3. Bueno, minus 3 times 2 is minus 6. When you move into the other side, plus 6. Entonces positive 3. Yeah. And finally, X. Remember, you have 3 components, no? Because our point solution is in 3-dimension context. Entonces we have 3 components, X, Y, and Z. In order to find the X, easy. You copy X plus 2Y minus 4Z equal minus 3. Okay. Entonces now, but I know very well que Z es 2 and Y es 3. Entonces X plus 2 times 3 minus 4 times 2 should be negative 3. Okay, entonces now X, this is Y es 3. Y es 3, ¿no? O Y es negative 3. Y es 3. This is 3. Entonces X plus 6 minus 8 equal minus 3. O X minus 2, because positive 6 minus 8 is negative 2, equal minus 3. Therefore, X alone is minus 3 plus 2, que es negative 1. Wow, I finished. The solution is the triple order minus 1, comma 3, que es the Y value. Let me Y value, X value, and Z value. Entonces, negative 1, 3, 2 is the solution. This is X, this is Y, this is Z. Pero no, I don't like this. No. Let's do it using Jordan. Why not? We continue. I suppose two more steps. 2 more steps. Yeah, 2 more steps. For example, 2 more, or 3 more? 2 more. No, 3 more. Suppose now, let me see, this is the next. I don't know. Yeah. So we have this step, and we have this step. Let me enlarge this. It doesn't matter the order. This. I suppose that this is an X. Let me, I want to check it. Oh, no, this is the next. Yeah, next. Yeah. This is the order, guy. This order, this is a piece of domino, and this is the last piece of domino. So this 3 step is to complete it, Jordan. Look. Do you see that matrix is exactly the same of this matrix? Okay. The only difference is this is white because the assumption is that we have two color, no? The white is the original before apply the transformation, and the yellow is the after the transformation. So in order to, let me see, let me try to understand, in order to create, oh yeah, this zero, because I create in the previous step 1 and the pivot 3. Well, you are doing easy. You multiply by positive 3, R3. Remember, this pivot indicates the row que contain the pivot plus R2, que es the thing I want to change, equal R2. Entonces you create that zero. Okay, good. I like. Now to create zero and the another element here above the pivot 3, the row operation that we're using is 4 times 3R3 is exactly the same pivot. Actually, we're using the same pivot to create 0 here and to create 0 here. Multiplication of the factor is the same number, but opposite sign. Okay, 0. Okay, cool. So we have in this step. And finally, the only guy que is not 0 is that 2. That 2. We happy? See, I create everything 0 except the pivot, que is 1, always. So you multiply, in that case, the pivot 2, row 2, by negative 2, because it's positive 2, plus R1 equal. And you get this matrix. Look at that. I like so much that part. This matrix is, I want to copy big. 1, 0, 0. 1, 0, 0. 0, 0, 1. Negative 1, positive 3, and 2. So basically, the only guy that stay alive is this one, the pivot. This one and this one. The rest is 0. And this is new matrix is called reduced row echelon form. Reduced row echelon form. So we have the echelon, just echelon, and we included this adjective, reduced row, that's when it's 0. So echelon is when it's stairs, like that. Now reduce is better because you see clear. Wow, x is -1. Look at that. X is -1. Y is positive 3. Y is positive 3. And Z is positive 2. And we get the solution. You see, wow, professor, this is too long. I know it's too long. That is a reason. Okay, you never solving this using this. I need to explain the mathematics behind this algorithm. Now, the mathematician create the algorithm, and the computer engineer create the software to do this. Okay? Question so far? Question. Do you follow me a little bit? A little bit, you know, is F or D. You need to know very well. Very well. Okay, let's move on to the software. Computer now. I open my laptop, or open my computer. And then I want to share the screen. Okay, let me try. No whiteboard anymore. No whiteboard anymore. Okay, here there you go. So now I share to the GeoGebra. Switching to GeoGebra. I suppose it's this. Okay, guys, you need to learn very well this. Do you see GeoGebra? Yes or no? Do you see the GeoGebra?
Yes.
Yes. Yes. Okay, cool. Now, in the algebra, when you open the first time, let me open the first time. Well, when you open the first time the algebra, you don't see like this. You see a little bit different because the algebra have different window. Different window. For example, you go to these three line and you select view. And you, for example, default is using no cast, using graphic and no spreadsheet. So basically, when you open the first time GeoGebra, you see something like that. Because basically it's similar to Desmos, que you create graphic in 2D or in 3D. So we have 3D also. Let me show you 3D graphic. Oh wow, 2D, 3D, and algebra. This window is algebra. This window is 2D graphic, and this is 3D graphic. Pero no, I don't want graphic. I want matrix. Entonces I go here again, go to view and select a spreadsheet. No graphic, and cast. Wow, what is a spreadsheet? A spreadsheet is similar to Excel. A spreadsheet is using to the matrix editor. You put a number in the spreadsheet. And you create a matrix and transfer to the algebra part. You see now. And after, in CAS is computer assistant software. O sea, the CAS is the brain que is solving the algorithm. Okay? Let's do it. I suppose that you see very well in this moment my GeoGebra. Yes or no?
Yeah.
Cool.
Yes.
You see some number that I put before. Okay. But in any place inside the spreadsheet, you put a number in my example. For example, I type in using the keyboard on my finger. Look, 3, tap, you navigate horizontal, 7, stop, navigate horizontal. So you press enter, you navigate vertical, change the line, -15, and -12. And this is my first equation. And you press enter. Now, of course, you change the line. This is 1. This is 2. -4. This is -3. Press enter. -4. Tab. -6. And 15. And 16. Do you see, guys, we have the same number of the example we are doing before by hand? Check and see. If you make it one stupid mistake, so you change one number or you change one sign, you are doing completely different problems. Therefore, don't expect the right answer. So you need to type in 100% accuracy. Okay, great. So now, see, you checking, I copy in one piece of paper here. Now this is a crucial moment. How we create the matrix? You select every number in my program. You press in the mouse right click and you see create. And you have different options, but I don't want the option. Only the matrix is the option I want because we are working with the matrix. And you create the matrix. Bang! And you see the matrix in algebra. This window is algebra. And one more time, I check in the numbers here, I make a mistake or not. 3, 7, minus 15, minus 12. 1, 2, negative 4, negative 3. Negative 4, negative 6, 15, and 16. Cool. Now almost I finish. I go to gas, get the brain of this. And you type in one command, let's call it reduce row echelon. You type R redo. Oh, I don't finish to typing. And you see the image is the reduce row echelon of what? Of the matrix, of course. What matrix? What is the name of that matrix? Is M1. Okay. M1. And you press enter. Bang! And you get the new matrix is equivalent to the original, is equivalent and the system, the solution is x equal -1, y is equal +3, and z equal +2. Bang! I finish. Okay. This is more complicated. I explained the kindergarten example, elementary, but in the not today no. Today I want to explain another example. Okay, we solving not necessarily determinate system. So in this case, you see frequently 3 equation and 3 variable. Oh, this is determinate. So when you have the same amount of equation and the same amount of unknown, this system is called determinate. Okay, cool. And determinate, hypothetically, you know that we have one solution, but no, you see before that maybe we have no solution or infinity many solution because the supposition at the beginning is that the equations are linear dependent. See, one equation is linear dependent, no independent. So you suppose que it's linear independent. In other words, it's different plane or different line or different hyperplane and more than 3 dimensions is called hyperplane. Un hyperplane, pero there are no geometric representation, no. In 4 dimensions, no. Some people try using artificial, but no. It's impossible. So the only geometry is in 2 dimensions, the plane, the classical rectangular coordinate system, and in 3 dimensions. Okay. The thing I try to explain is that next time we dedicate to solving 1, 2, 3, 4, 5, 6, 7, 8, 9 example, maybe more, in which I give you the system, you only by hand create a matrix, you open GeoGebra. So I recommend that everyone open GeoGebra. So simultaneously you open the lecture and you open the GeoGebra in another window, no? And you follow me in the computation because you have to learn this anytime. Okay? Entonces, en the rest of the time, bueno, no. Okay, let me try. Okay. Let me try. For example, in the PowerPoint I said today, I have another 2 examples, example 1 and example 2. I try to explain example 1 because it's relatively easy. It's long. So I left you another example 2 that's more complicated because of 4 equations and 4 unknown. Okay. So now let me try to explain something theoretical. Look, suppose 99% of the time, 99% of the time, you have, same numbers of equations of unknown. So 3 equation 3 unknown, 4 equation 4 unknown. Okay, this systems is called determinant. Determinant, like an adjective, ed. Okay, because we have enough information. So suppose in 3D, each equation is a plane. We have another plane. And we have another plane here. And the intersection is the point. Solution. But this is the supposition that the plane or the line, whatever, suppose this is in 3D. It's super hard to see. But in 2D it's more clear. Huh? We have one line, two lines. Oh, solution, unique solution. Okay, because we have the same, so in 2D, we have two equations and we have two unknown. But, okay, listen. Remember this formula, okay, explain one day. Degree of freedom is equal number of variable minus number of equation. In this example, for example, we have number of variable 2. Number of equation is 2. Because we have two equations. But 2 minus 2 is 0. Entonces, if you suppose que the equations are linear independent, the degree of freedom is 0. That means que the solution is a point. Degree of freedom 0. But this is the supposition que the equations are linear independent. The beauty of this is que the Gauss-Jordan elimination process discover, at the beginning you don't see, but discover if one equation inside the system is dependent and eliminate completely. For example, you see next lecture, not today, of course. Suppose a system que contain two equations. Suppose 2x, I promise you we're solving this next time, plus y minus 6 minus z minus c equal 4. Wow, one equation, nice, 3 unknown. And we have minus x plus y plus 3z equal 1, equation 2. And that's it. And this is my system. So my system is underdetermined. Underdetermined. Why, professor? Because we have 3 variables, x, y, and z, but we have only 2 equations. The interpretation of this is that we have, like a lack of information. It's not complete the information. However, suppose that both equations are linear independent, entonces is the first equation represents a plane, and the second equation represents another plane. Suppose another plane like that. And the intersection between the plane is a line. So now, how you apply that formula? You apply that formula like that. Degree of freedom is number of variables 3, x, y, and z. But we have 2 equations. Degree of freedom 1, so degree of freedom 1 represents line. Because the line is the object in 1 dimension. However, in the chapter 2, I don't understand very well. This is too more complicated when you have 3 variables. It's very complicated. However, using the matrix, you see super easy. I want to explain last class. But I anticipate something, no? Okay, we're solving any system, determining, underdetermining, or overdetermining. Suppose overdetermining. What means overdetermining? It's more equation than, oh no, suppose. Let me try to find one example. No, I don't have. Can I create one mentally? Okay, suppose x plus y equal 30. 2x minus 5y equal 20. I don't know, 20x minus 60y equal 100. Equation 1, equation 2, equation 3. Entonces, wait. Too much equation. This is over-determining. Over-determining. Entonces, we have two variables only, degree of freedom. Entonces, you get contradiction. Degree of freedom is 2. Two variable. We have three equations, -1. Wow, what the hell is -1? No. Okay. Suppose que this equation is a line because it's 2D. And this equation is another line because it's 2D. And suppose que the third equation is another line and by coincidence have a common point. So we have solution maybe. But the most probability is no solution because you have one equation, two equations, and another equation is no common. Entonces it's no solution. Okay, entonces now we expect at the beginning one solution, infinity many solution, or no solution, because for example, suppose that the three equations are depending, yes, the same equation, it's the same line. Entonces now we have infinity many solution, no? Okay, entonces now you don't know, it's a mystery. However, using the matrix elimination process we studied today, I want to study in detail next lecture, no now, the possibility of this. Of course, to save time, we are doing not by hands, using the computer. However, in the tests, in the homework, in the review package, we are doing something by hand, but not too much. So a specific row operation can indicate you. Okay? Okay, so in the 5 minutes I have, let me try to do my best. Look, let me try to do at least one example I have in the piece of paper. This is example 1 for the next lecture. X minus y equals 6, equation 1. 2x minus 3z equal 16, equation 2. 2y plus z equal 14. No, 14, no, 4, sorry. 4. And the question always is say solve the system. Solve. Of course, you can do by hand using the traditional way we studied in the chapter 2, because it's too easy. Or no, not too easy, but it's doable because it's 3 equations and 3 unknown in 3D. It's one problem in 3D. But no. We anymore doing it in this way. You are doing using matrices. But the first thing you should do is write the augmented matrix associated with the problem. Remember, the first row is the first equation. The first column is x. The second is y. The third is z. You separate by vertical line, and this is the right-hand side number. This is the organization in matrix language. Now, let me erase this line. So my matrix is 1, -1, 0, and 6. Do you follow me? This is my first equation, and matrix language is my first row. Row 2, S2, S0Y, no Y missing, -3, 16. And row 3, the third equation. X is missing, Y is 2, C is 1, and the right hand side 4. Boom. By the way, this matrix, the dimension is 3 by 4. We can have 3 row 1, row 2, row 3, corresponding with any equation, and 4 column because we have the 4 variable, an additional column of the right hand side. Everyone so far? Okay, so now next time I want, okay, remember today is the due date for send me on by email the test number 2 on paper and submit the test number 2 and the corresponding homework online. Are you clear on this? Sure? Sure? Okay, entonces we continue Wednesday. Yes, sir. Okay.